Hello again, friends. We're going to do lesson 4, which is sort of weird and not directly related to anything else we're doing, but whatevs, we'll figure it out. What we're going to be doing is converting. I feel like this is something you've done, and it's just about setting up, I call them dominoes, which is really old school, and you probably don't even know what it is, but it's a way of like setting things up that will knock each other out. And in order to do that, you need something on the top that matches the bottom because they will cancel. So let's dig in and I'll show you what I'm talking about. Here it says to convert 16 years to seconds. So I'm going from years to seconds. So think about conversions. I do not know how many seconds are in a year, but I can start and I can think, okay, well, 1 year is 365. I know that that's 365 days. So now I've taken a step towards days. So then I can think, well, I also know that 1 day is 24 hours. Then I know that 1 hour is going to be 60 minutes and 1 minute is 60 seconds. So I'm just kind of thinking about all the conversions that I have that will get me from one place to the next. Then you have to start with what they gave you, 16 years. Now I'm going to start setting up conversions, or what I call dominoes, meaning this is years on the top because this is all over 1. So to get rid of it, I need years on the bottom, and then I need to take a step towards seconds. So I'm going to use this conversion and say 1 year, therefore not plural, English people, 1 year is going to be 365 days. So now I've gone from years to days. Okay, now I need another conversion. Since the day is on the top, I'm going to need days on the bottom, and I have a conversion for getting to the next step. 1 day is 24 hours. So now the days cancel because anything on the top that matches the bottom cancels, and I'm at hours. So I use another conversion and say, well, I do know that 1 hour is 60 minutes. An hour on the top and bottom cancel. And then last, I can say, well, there's minutes on the top, so I'll need minutes on the bottom. And the conversion or relationship is that 1 minute will be 60 seconds. When you get, this is your start, and this is where you want to end. So when you get to the thing you're trying to end with, which in this case is seconds, you stop. And you now have all the conversion tools that you need. The years canceled, the days canceled, hours canceled, minutes cancel. And now you're going to multiply all the numbers on the top and then all the numbers on the bottom and reduce. And again, we're trying to get towards using a graphing calculator. And even if you don't use it to graph, it just does a lot of other math for you significantly easier. So if I take all the numbers on the top, 16 times 365 times 24 times 60 times 60, I am going to get 504. I did these on my calculator earlier, so hopefully that's all good. And then that's going to be over. But on the bottom, if you take a look, you're multiplying 1 times 1 times 1 times 1 times 1. So the bottom's just going to be 1, which doesn't really change the value. And so I would say this is going to be 504,576,000 seconds. Because the question was, how many seconds are in 16 years? Now, you don't always know the conversion. In this next one, you may not know it, so they help you a little bit. Convert 5 miles to yards, but the conversions they gave us right here are ones you might not otherwise know. I feel like you probably know that 1 yard is 3 feet, but you probably don't know that 1 mile is 5,280 feet. So I write down what I was given, 5 miles. And I start a conversion with, since this has miles, I'm going to need miles on the bottom. Well, the conversion I have for that is right here. 1 mile is 5,280 feet. Now the miles cancel, not the numbers, just the conversion, or excuse me, just the label. I'm trying to get to yards. I have feet on the top. I need feet on the bottom. And the relationship between feet to yards is that 1 yard is 3 feet. So this time the 1 is not on the bottom because it's not true that 1 foot is 3 yards. It's true that 1 yard is 3 feet. So I'm going to do what I did before because now the feet cancel and I'm done because I have yards on the top, which is what I need. So I stop and then I think, okay, now I need to multiply all the numbers on the top. So I'm going to have my 5 times 5,280 times 1. I got 126,400. And on the bottom, I do not just have all ones. I have 1 times 3. So I get a 3. But I'm going to divide that, and it actually comes out pretty neatly. I get 8,800. And keep in mind that I'm trying to figure out how many yards there are in 5 miles. So I will label it as yards. Now the next one takes it to another level because you actually have 2 different things you're trying to convert. You're starting at 45 miles per hour and you're ending at feet per second. So I need my miles to become feet and my hours to become seconds. And so you can convert either the distance from miles to feet or the hours to seconds first. It really doesn't matter. But you always have to start with what they gave you. Now this one is miles per hour, and so that's going to be over miles per hour. Okay, let's convert, I don't care, time first. If we do time first, we ignore the miles because miles is not time. And so I'm going to transition my time from hours to seconds. I have hours on the bottom, so I'll need to have hours on the top in order for them to cancel. And I want to take a step in the right direction, so I say 1 hour is 60 minutes. Hours cancel, but I'm trying to get seconds. So I do another conversion. Minutes are on the bottom. I'll need minutes on the top to cancel. And what my conversion is that 1 minute is 60 seconds. Minutes cancel. So that part so far, those numbers will get me to a per second because it's going to be on the bottom. So what I want to do now is I want to focus on, okay, how do I then convert the miles from way back here into feet? Well, up here they gave me a direct conversion. So even though I've been using these other conversion factors for time, I'm going to put one here to use for distance. Now the miles was on the top over here at the beginning, so I'll need miles on the bottom. And in this case, I only need one converting tool because I know how to get from miles to feet. It says up in the problem above that 1 mile is 5,280 feet. So then this mile from way back here cancels this one on the bottom because one on the top, one on the bottom cancel out. So that's going to leave me with multiplying the numbers on the top, which is 45 times 1 times 1 times 5280. And then on the bottom, and that'll give me a value. What did I get? 237,600. And then on the bottom, I have 1 times 60 times 60. And so that's going to be 3,600. And when I use my calculator to divide that, I got 66. And keep in mind, the whole idea was to get feet on the top and seconds on the bottom. So feet per second. Now, if you change the distance first, the only thing that would happen is this conversion factor would end up sooner, but you'd have the same conversion factors. And then you would end up with the same answer. All right, so here I'm gonna work 8 hours and earn $36. What's my earning rate? A rate is how much are you making per one of something. So I wanna know how much am I making in dollars per 1 hour. So I think, well, you can do this a couple different ways. One is probably familiar to you. If I have $36 in 8 hours, then how many dollars will I make in 1 hour? That'll figure out my rate. Some of you might just do mental math, whatever it takes for you to understand it. This is going to turn into 8x equals, I'm just cross multiplying 36 times 1, which is obviously 36. To get x alone and figure that value out, I would divide. So it turns out to be 450 when I take 36 divided by 8 per hour. And per 1 hour is the rate. So if you go and they're like, oh, bananas are $1 a pound, that's your rate. It's per 1 pound. So then, like now, if I'm like, well, what if I work 30 hours? What if I work 100 hours? I can just multiply my per hour rate times the time that I'm working. Okay, I'm going to buy 15 Starbucks coffees, which is actually never going to happen, at $15.25 per cup. This is my rate. This is per 1 cup. What's your total? All right. Well, I'm buying 15 of them. And then basically that's 15 cups. So when you go to do your conversion, if you want to set it up like we were doing above, you'd say that's $5.25 for each one cup. So the cups will cancel, and then the product of $5.25 times 15 is the $78.75, because all you have left for a label is the dollar sign. Now you might not have to set it up like that. You might just be able to figure your way through it, which is fine. Okay. When we're starting now something a little bit different. When it says solve the formula, blah, 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 for R, what it's telling you to do is to get this alone. And you get it alone by mathematically removing every single other thing. So, in this case, I start off with C equals 2 pi R. I am trying to get this R alone. So ask yourself, how are the things connected? And then use the opposite to get rid of it. So the 2 and the pi are connected to the R by multiplication. So I will remove them or get rid of them by division. That's gone, and I've accomplished my goal. I solved for R. So I rewrote the formula starting with R equals. Here I'm supposed to solve for B. So my goal is to have B equals whatever some stuff is going to be. And the B value is right here in the middle. And so I'm going to just go through there and get it alone. So if I start with this, one of the things that's happening to B is it's getting multiplied by a half. So if I want to undo that, I'm going to multiply that side by 2, which will multiply that side by 2. These are gone. So now I have 2A equals B times H, and I'm still trying to get the B alone. To do that, I have to undo the multiplication using division. So B equals 2 times capital A over H. And this gets used a lot more in science when you're rearranging formulas in physics, for example, but you're solving for a variable. So here, solving for Y means get Y alone. So Y has to be by itself. It's currently attached to this -4, and so that's going to be the last thing to leave. So I look at whatever else is over there. The 9x, to get rid of that, I'll need to take it away to the other side. So on the left, I get -4y left. And here, I don't really put the -9x together with the 7 because they are not alike. One has an x, one does not. Now I need the y alone. So I'm going to divide everything by -4. So I'm just going to write up here so it shows a little bit more space. Uh-oh. My computer that I was using just shut down, which is only bad because I don't have a calculator with me. I'll figure it out. So I'm going to divide everything by -4, each piece. So y equals 5, I was subtracting. Y is going to equal, the negatives cancel one another. So positive 9/4 x. And then here, a positive 7 divided by -4 is going to be a -7/4. And now my computer is restarting. So I solved for y. And that's going to actually be something we have to do pretty commonly. So here I have 2y plus xy equals 6. And I'm trying to get y alone, but it's tricky because there's one here and here. We are working backwards. We are undoing what we normally do. And so what we would normally do to get a y everywhere is we would have distributed it. That's how it got passed out to everybody. is you distribute. It's like papers. If I distribute papers, everybody gets one. So what you have to do here is gather that y out in front. You can't have y's everywhere in the problem if you're getting them alone. So I'm going to do like GCF, basically, greatest common factor, and say, hey, everybody's got a y, so I'm going to go ahead and take that thing out in front. And when I do, this term, when you divide it by y, becomes a 2. And then this term, when you divide it by y, becomes an x. Keep in mind, my goal is to solve for y. I'm trying to get y alone. So, okay, that's fine. To get y alone, it's currently multiplied by this whole parenthesis business. So to get it alone, I'm going to divide it by that. So I have my y times 2 plus x equals 6. And I'm going to divide out that whole 2 plus x business. That cancels, and I've done what they told me to do. I solved for y. Y is going to be 6 divided by 2 plus x. And you can have x plus 2. You can have the parentheses or not. I don't really care. Okie doke. So the grand finale of these notes, I know you've been looking forward to this moment for a very long time, is a word problem. I would 100% know how to do this. It's describing a situation. So draw out, write out, think through the situation so that you are able to figure out your equation. Because you can solve the equation. You just need some help getting it set up. So you are hanging 5 posters in the hallway at school. They are 3 feet wide. The hallway is 39 feet long. That's a total. Keep in mind, that's my total. And then there should be an equal amount of space between the ends of the hallway and the posters and between the poster. Oof, okay. So I have 1, 2, 3, 4, 5 posters because it says so. Each one is 3 feet wide because it says so. The hallway is 39 total. And then the spaces between the ends of the hallway and the posters in between them are all the same, but unknown. So I'm going to call it X. And X is going to represent the spaces, the space width for each of them. And it wants them all to be the same. It's not like, oh, they're double or triple. They're all the same between the posters and then between the last poster and the wall. So look at that, think about it, and then don't make it harder than it is because you can create a situation. Total means you are going to add them up. Like if you're trying to figure out your total money, you got to add it up. So I have 1, 2, 3, 4, 5 posters, and they're each 3 feet wide. That is using up 15 of my feet. Okay, now I'm going to be looking at the X's, so I'm just going to count them up. I have 1, 2, 3, 4, 5, 6 X's. So I'm going to write that into my equation and say, all right, well, I have 15 feet used up by posters plus 6 of some unknown width, which is what I'm trying to find. And they have to add up to the total. And so then the total is going to be the 39. And now I'm going to solve for X because X is my space width. So I take away 15. I have 6X equals 24. And I divide by 6. And the posters are all 4 feet apart. So I have 4-foot spacing between the posters. So you can solve the math. That won't be tricky. This is the part where you have to really take your time to maybe sketch it in order to make it obvious to you how to set up the equation. Now I think you know everything. Thanks, guys. Bye.